Hello everyone. Today let's solve the Leetcode problem number 191, number of 1 bits. So what the question says, write a function that takes the binary representation of positive integer and returns the number of set bits. It has returns the number of set bits that it has. So we have to return the number of set bits it has, right? Also known as the Hamming weight. So it is also known as Hamming weight they have given. Let's come to example 1. So input n equals 11, output they have given 3. Why the output is 3? They have explained here. The input binary string 1011 has total of 3 set bits. So the output will be 3. They have clearly mentioned here, right? Same thing goes with the example 2. So what we will do, initially let's try to write the code and I'll explain by taking the example 1. You can check for the example 2, right? So initially what we will do, let's initialize the counter first to keep track of the number of set bits, nothing but ones in the binary representation of n. So I'll just give this set bit count equal 0. Right, next let's loop loop continues until n becomes 0, right? N has to become 0. Loop continues until n becomes 0, meaning that there is no more set bits are left. Until no more set bits are left, the loop will continue, right? So I'll just make use of while loop in this case, while n not equal to 0. So then the expression here, I'll just write this one and try to explain. Equals, let's go with n minus 1. So here this expression, basically what it is doing is, what it does is, it clears the lowest set bit of n. Nothing but it works by turning off the rightmost 1 bit in n. So this one, this particular line. So yeah, then what we will do, we will increment the set bit counter as we have just cleared 1 bit. We are incrementing the set bit counter now, right? So how can we increment? Simple. I'll just copy the same thing here. Let's increment the set bit counter. Next, what we'll do, we'll return the total count of set bits in the binary representation of n. That's what we want, right? We want, we have to return the number of set bits that it has. Nothing but at a function that takes the binary representation of the positive integer. Nothing but they'll, in this case it is 11. We need to return the number of set bits basically the 11 has. So for this we have got the answer 3. So here in this case what we have to return? We have to return the set bit count. So let me format the code and hit the submit. So the code works absolutely correct. So let's consider the example 1 and try to implement the same accordingly with the. So let's consider this example, right? So input they have given n equals 11. In the binary representation of 11 into decimal is 1011. So the binary representation of 11 in decimal is 1011 in binary, right? So next, what is our main goal? To count the number of ones in the binary representation, right? So we'll do this step by step. Initial step is basically now n is 1011. Let me take this one and set bit count. I'll just take this one SBC. Set bit count is initially 0. Initially we have set this one to 0 here, right? So this line. So this way, the initial binary representation of 11 is 1011 and set bit count is initially set to 0. This is the first step. The first iteration is nothing but before operation n equals 1011. We will come to this step. Now we will compare. So here it will be 1011 and 1010, right? So n end equals n minus 1 we have given. Nothing but 1 0 1 1 and 1 0 1 0 1 1 and 1 0 1 0 it will be. So we know that here this will be, when we perform operation, this one and operation, it would be both the one has to be 1, or else we will get 0 itself, right? Here this 1 is 0 1 0 1. This will be 1 0 1 0, right? So we'll update the set count to 1. Now n is, next step 1 0 1 0. Now set bit count is 1. Next step, what we'll do? Second iteration. So before operation, this will be n is 1 0 1 0, right? So we will come to this one again. So we will compare 1 0 1 0. Sorry, just give me a second. Yeah, 1 0 1 0 and equals n minus 1 they have given. Nothing but 1 0 1 0 and 1 0 0 1. 1 0 0 1. This will be again. If you find 0, it will be 0. Both has to be 1, right? So 1 1 1. Nothing but now we got 1 0 0 0. N will be 1 0 0 and set bit count will be 2 in this case, right? So the third iteration will come here. Before operation is nothing but this one. It is 1 0 0 and the operation again will come here. N and equals, so n minus 1. That again same thing. Here what we will see, 1 0 0 with 0 1 1. Nothing but 0 0 here 0 0. We have got the answer 0, right? So now n is 0 and set bit count is nothing but 3. So this is end of the loop. We are performing loop until n equals 0, right? So now this is end of loop, and so the loop exits, right? So the final output is set bit count we got here is 3, if you can clearly see here. So, and here the output that we want is 3 as well. Now I have written something on it basically. So the output they have shown here is 3 as well. So there are 3 ones in the binary representation of 11. So there are 3 ones in the binary representation of 11. So here we can clearly see there are 3 ones in binary representation of 11. Nothing but 1 0 1 1, right? So we have got the answer 3. The answer is correct. So let me delete this one. So here. So what will be the time complexity and the space complexity? Just give me a second. The time complexity would be big O of k. Why the time complexity is big O of k? Because it is proportional to the number of set bits k in n, as the loop runs only once for each set bit. So the time complexity would be big O of k. So what will be the space complexity? The space complexity would be big O of 1. Why big O of 1? Why the space complexity would be big O of 1? Because it is, we are not making use of any extra space other than few variables. In simple words, we are not making use of any extra space, right? So the overall space complexity would be big O of 1. So let me comment this. Let me hit the submit again. So this works absolutely. So this is it.